ये तो प्रकृति का नियम है।
है ना? अब ज्यादा मत बोलो।
इस टेबल में पूरा मिट्टी मिट्टी हुआ है ना।
तो समझ
हम्म। अरे बाप कम लिखे भाई। है ना बताएं। भाई लेके बाद जो लिखिए बेचला सिकंजी यार।
नहीं आ
नहीं। ट्वेल्थ फेल हो गए।
ट्वेल्थ फेल हो गए।
ट्वेल्थ का पेपर डाल देना है साहब।
हैं?
ऐसा ट्वेल्थ का पेपर डाल फेल हो गए।
अच्छा।
कहता है जो दो तीन लड़े से हमारी में से देख देख लिखना ऐसा बढ़िया गली बगल देख सब पास हो गई ना। कहता है, एक दो ना चार विषय में फेल बन जानी। तो कहता हूँ, अगले साल फिर बतावा दे भाई क्यों। वेज चिकन जी। ये क्या है? पनीर लिया। चिकन जी पीनी है। उनको खिला देंगे। क्या ठीक है।
मंदिर के बैठ गया चले।
इससे क्या लेगा ठीक है। अभी बच्चों को ले जाना ट्यूशन में। पनिया देगा। पनिया देगा। तो अच्छा हम ऐसा दिख रहा है क्या ऐसा। मैं ऐसा दिख रहा है। हेलो श्रेयसी गुड इवनिंग। गुड इवनिंग श्रेयसी। एम आई ऑडिबल श्रेयसी।
Sir, good afternoon. Am I audible?
या यू आर ऑडिबल।
Okay.
ओके सो लेट्स स्टार्ट द क्लास नाउ।
Yes.
Yesterday we completed about the AC currents, right?
Yes.
Okay. Okay, we have here, now we are left with kinetic theory of gases, states of matter, ideal gas equation, ideal gases, various types of speed, kinetic energy of ideal gas. So this is the topic we are left with. We have done electromagnetic induction and alternating current. Faraday's law of induction we have done. So can you state Faraday's law of induction?
Sir, it is the
Hmm.
sir. Can we say
See,
it is the
according,
phenomena, or do we say it is the method by which we vary the magnetic field lines in order to produce current?
okay. So according to the Faraday's law of electromagnetic induction, first point is that varying magnetic flux creates electric current, or varying magnetic flux is the source of electric EMF. Then
Yes.
second point we had done that the induced EMF is directly proportional to the rate of change of flux. So induced EMF is proportional to minus of d phi by dt, where we say d phi by dt is the rate of change of flux with respect to time. So this is the second statement we had done for the Faraday. So that means the faster you change the flux, the faster the more will be the induced EMF. By EMF
Exactly.
we mean the potential. So how the if we use this phenomenon, so let us see how the electric current is generated. So for this we have two options. We take two magnets here. We take a magnet and we take the magnet such that these are the two poles. We have the north pole and south pole of the magnet, and inside this we keep a coil. So here we keep a coil inside this magnet, and we rotate this coil inside this magnet. So when we rotate this coil inside the magnet, the magnetic flux which crosses this wire, it changes. The magnetic flux linked with the coil changes continuously, and hence we find an induced EMF in this coil. So the more fast you rotate, more fast will be the change of flux, and hence greater amount of electric current will be generated. So there are two ways. Either you can keep the magnet fixed and keep this coil moving. So this phenomena you might have seen in the case of small electric generators. What we call diesel engines or small generators are there, in which the a diesel is used to move this coil in a magnetic field. You have an alternator, and in that alternator mainly consists of a magnet and a coil. So the coil is rotated with the help of the diesel engine, and then the induced EMF is produced in this coil.
Yes.
Okay. So this is how the Faraday's law of electromagnetic induction works. Then there was a small topic of AC voltage applied to a conductor. So just like this, we have a number of electrical appliances. Like up to now in your grade 10, you have seen about the electrical appliances which are only resistive in nature. Only resistive in nature means we have only heard about the resistance. We have heard
Yes.
about what is resistance. So we know the resistance of a wire. So such a circuit in which there is only a resistance, such we call that circuit to be a purely resistive circuit. Okay, but apart from this resistive circuit, there are some other circuits also. Apart from resistance, you find some other devices. Like we say, we have a device called inductor, and we have a device which we call as the capacitor. So these are two different devices. The behavior of AC or alternating current to these devices is different. For example, we have seen for the resistive circuit or for the resistors, if our circuit consists only of a resistive wire, if it only consists of resistances, so we call that the circuit is purely resistive. And here the effect of AC is similar to that of DC. The effects are almost similar with AC and DC for an AC, for a resistive circuit. But it's different for an inductor and a capacitor. An inductor is similar to a solenoid. So a coil, which we generally call as an inductor. So behavior of alternating current towards an inductor is different, because here every time the current will grow, come down, grow and come down. So it will magnetize this, then again demagnetize, then again magnetize it, again demagnetizes. And this cycle of magnetization and demagnetization, it will be carried on for a cycle of 50 hertz. That means every second there will be 100 times magnetization and demagnetization of the solenoid. So the behavior of AC towards an inductor is different as compared with the resistance. It's not that uh, if you increase the EMF, the current will increase. No. So first EMF increases, then after that when the EMF starts decreasing, then current decreases. So there is a specific relationship for an inductor. For a capacitor, there is a different relationship. A capacitor is a device which is used for storing charges. Okay. So as we have seen a capacitor, if you have observed a fan, so generally your ceiling fan, it consists or it has a small device, circular device like this, which we call as condenser or capacitor. Okay. So such a device is called as a condenser or capacitor. It's generally represented by these two lines. We call it as a parallel plate capacitor. So the behavior of AC towards capacitor, it's also different. Okay. So as this can store charges and build its own potential. So the behavior of AC towards the capacitor will be different. Here for AC, for resistance, the behavior of AC is same for both AC and DC. But for inductor and capacitor, it's different for both AC and DC. AC behaves differently with an inductor as compared with DC, also with capacitor. Okay. If a capacitor is applied inside a DC circuit, it would make the resistance of the circuit go very high, infinite. So we'll learn about these instruments later, but we just know that yes, there should be something from the resistance. From the resistance means for the resistance, both of them they behave similarly. Now today for we are starting with the kinetic theory of gas. The kinetic theory of gases, it is a theory of gas which explains the behavior of gases. By the behavior of gases, what do we mean by the behavior of gases? We are able to predict taking into certain assumptions with the help of the kinetic theory of gases, we are able to predict their nature, we are able to predict their behavior, pressure, volume, temperature. So everything can be predicted with the kinetic theory of the gases. Okay, as you know, to predict the state of a gas, we need three variables. There are certain thermodynamic variables which are required for the prediction of the state of gas. So if you predict the state of any gas, the state of, as we know that gases, they can occupy any given volume, right? State of gas. So if you are keeping a gas in a container, so it will occupy the complete space available to it. Gases will occupy the complete space available to them, right? So it will take the complete volume. But what other effect will it have about the gas? Other effect means, suppose if you increase the volume of gas, suppose you kept a gas here in this container, then after some time you brought it into another container which has a greater volume. So what are the effects that will occur? Here the gas had the volume V, and here the gas has a new volume V dash. So will there be any change in other variables? Other variable means the gas exerted some pressure over here. Let the pressure that the gas exerted is P. Let the gas here had the temperature T. Now you have increased the volume. So what effect will there be on pressure and temperature? Okay. So these are the three thermodynamic variables. We discuss here about the gases in terms of thermodynamic variables, and the thermodynamic variables which we discuss for the gas are pressure that is exerted by the gas on the walls of the container. We discuss about the volume or the space occupied by the gas, and then temperature of the gas. So they are all related with each other. How they are related with each other? To study all these three, we take either first any one of the variable to be a constant and see the effect of one on the other. Like sometimes we keep the volume constant and take the variation of pressure with temperature, how the pressure varies with temperature. Then we can keep pressure constant and study the variation of volume with temperature. Then we can keep temperature constant and study the variation of pressure with volume for a gas. So all these studies, they are studied by different scientists, and we call them, they put forward certain gas laws. Okay. So another thing here, we will be studying about the internal energy of the system. So what do you mean by the internal energy?
I did not get it, sir.
Do not know. Okay. So internal energy, it means the total energy possessed by a gas. Okay. As we know that the molecules of a gas, they are in continuous motion. And this motion of the gas, is motion of these gas particles is due to their internal energy.
Okay.
Right? Since they are possessing some amount of energy, and that amount of energy is either possessed due to their potential energy or due to their kinetic energy. See, since the if we observe the two molecules are very close to each other. Okay, so if I observe that two molecules are very close to each other, they have some energy due to their position. Why their position? Because if the two molecules come close to each other, they either attract each other or repel each other. Okay,
Yes.
so due to their attraction and repulsion, even if there is no attraction or repulsion, but if they come very close to each other, so charging will be induced in them. Like it's like this. Suppose if you have a positive charge nucleus and surrounding this nucleus you have the electrons which are revolving. So if you have one atom coming close to another atom, so the electrons of one atom will repel the electrons of the other. As a result, there will be an induced dipole. There will be an induced charging in both of them, and hence an establishment of energy in between. So due to the position, there is an internal energy of the system. Also, the internal energy of the system is due to the molecular motion. Since the molecules, they are continuously moving. Since the molecules are continuously moving, so they are possessing some amount of kinetic energy. Okay.
Right.
So this kinetic energy possessed by them is also we observe as a internal energy. Okay. And this can be measured with the help of temperature of the gas. If the gas has a higher temperature, so we can say the molecules of the gas, they have a larger amount of energy.
Right.
Okay. And
Yes.
if the temperature of the gas is low, so the molecules will have a lesser amount of kinetic energy. Okay. Creating more temperature, creating more temperature, creating more temperature increases the internal energy, and decreasing the temperature will cause a fall in the internal energy. That means if
Okay.
you this is how we can explain the freezing of water. If you try to freeze water, so what you are doing, you are taking away heat from the molecules of water. And when you are taking away heat from the molecules of water, the motion of the molecules of water is decreasing. Earlier, they were more random to move, and hence it was in the liquid state. Now, when you take out heat from them, so the molecules, they specify their positions, their random motions decrease, and hence they become ice because of
So,
the
sir, if
decrease.
there is a less internal energy, very less, then they start moving close to each other.
Yeah, then their positions become almost fixed,
Okay.
and their motions, they become restricted, they
Right.
decrease. Okay, this is the way how we are able to take the how we are able to liquefy a gas in the similar way. This is the
Right.
way how we are able to solidify different substances. Just taking out heat from them will make the molecules stable, will make the molecules freeze their motions. And if you provide them heat, it will increase their randomness, it will increase their motion, and hence you will observe a change of state. For example, if you supply heat to ice, so the molecules will get more amount of energy, they will start moving more, and hence they will turn to the liquid state. If you give them more energy, so they will turn to the gaseous state, that is the vapor state.
Right.
So here in this chapter, we will be mainly talking of the gases. So gases possess their internal energy, and we can say that internal energy can be represented as a function of kinetic energy, and this kinetic energy is directly dependent on the temperature.
Right. Yes.
Okay, so greater the temperature, greater will be the kinetic energy, greater will be the internal energy. So if you decrease the temperature, the kinetic energy will decrease. This is how we relate with them. In the similar way, we have related about the absolute zero. As you know, the temperatures are measured in degree Celsius, they are measured in they are measured in Kelvin and Fahrenheit also. Okay. So as we know that the Kelvin scale is the scale which is always positive. Kelvin scale is the scale which always remain positive. Okay. So how it always remain positive? We have predicted, we have studied the variation of volume with temperature. Okay. So keeping the pressure as constant, keeping the pressure constant, we are not increasing the pressure and we just study the variation of volume with temperature. So a graph was plotted by Charles
Charles
between,
Darwin.
no, not Charles Darwin.
Okay, okay.
So here he plotted a graph between volume and temperature. Okay. So he plotted a graph between volume and temperature. So he got a graph which was linear, almost linear shape like this. Got a graph as like this between volume and temperature. So he thought, if I extend this graph, if I take this graph beyond like this, if I take this graph something like this, just backward, if he extends the graph backwards, so this would meet the temperature, this would meet the temperature at negative here minus 273.15 degrees centigrade. So this is
Right.
the temperature at which the graph of volume and temperature will coincide. That means at this temperature, we will observe that volume of a gas is zero. However, it's not possible for a gas to have a zero volume. Is it possible for any
No.
gas to have zero volume? No, because gases, they themselves are made up of molecules, and those molecules also occupy some space.
Exactly. Yes.
Okay. So the space occupied by the molecules cannot be made to zero. Okay. So he thought, even if somehow we are making all the volume of the gas to be zero, so the temperature that we would require is minus 273.15 degrees centigrade. Okay. Since it's not practically possible to make the volume to be zero, so therefore it is also not practically possible to achieve a temperature of minus 273.15 degrees centigrade. That
Yes.
means you cannot cool a substance beyond a temperature of minus 273.15.
That's the
Okay.
maximum.
So yeah, that's the minimum possible temperature that is possible.
Right.
So what,
Exactly.
yeah, exactly. So since you cannot make the volume go beyond zero, or you cannot even make the volume to be zero. Okay. So that is how he was able to predict that this is the least possible temperature which can ever occur in this universe. Can ever occur in this universe, because beyond that it's not possible. If you at just if you even try to reach this temperature, your volume will, all the molecular motion will stop. Okay, the energy of the molecules will vanish, their motion will stop. Okay, and you assume that if all the molecular motion had stopped, it has freezes, even the electrons have frozen,
Um,
everything is frozen. Okay, so that means such a temperature is not possible. Okay, so that is why this temperature was taken to be 0 Kelvin. So you cannot have a temperature less than this. If you try to achieve a temperature smaller, just while reaching this, if you are somewhere there, let's say minus 200 or let's say minus 196, coming up to here only, everything will solidify. Okay. It will start solidifying. Even the gases will start solidifying, freezing up all the molecular motions.
yes.
Okay. So up to now, we had just thought that, yes, how can someone predict that this is the least possible temperature? We can make even something cooler than this. But no, you cannot make anything cooler than 0 Kelvin, because if you try to reach that temperature, before that temperature all the molecular motion will stop.
So is
Okay.
it exactly Alimented, sir, like anyway.
And see, if you try to cool anything, the only way how the refrigerators work here, if you try to see how your refrigerator or how your AC works. So in your refrigerator, you have a CFC or any coolant is there, which is circulated inside this refrigerator. Okay. So when the gas is circulated inside this, let us say the gas is circulated here. First of all, what happens? The gas is compressed. Okay. Initially, the gas is compressed in a chamber. You have seen in the refrigerator just below, you have here a compressor.
Right, yes,
And
sir.
the compressor compresses the gas. When the volume of the gas is increased, if you increase the volume, keeping the pressure as constant. So if you increase the volume, the temperature will fall since pressure is constant. So here the gas expands. When the gas passes through these pipes, it expands and hence cools down. So if gas cools and passes through this refrigerator, it absorbs the heat from the surroundings, right? So this is how the gas is passing, it's taking away heat from the substances and then again getting compressed and so on. The cycle is going. Okay. What about if the gas itself freezes? If the gas itself freezes, so it will not be able to move.
Right, sir, yes.
Okay. So as we know that molecular motion will stop before 273.515.
Yes,
If the
sir.
molecular motion stops before this only, so there is no way that you can reach this temperature of 0 Kelvin. Okay. Even your mercury will also freeze before that.
Okay.
Okay. And before that temperature, you will be having your superconductors. Because molecular motion ceases, every molecular will stop its randomness motion will stop, and therefore the resistance will decrease. We have observed that the resistance of a substance decreases with temperature, right?
Yes, sir.
Increases with temperature, and if the temperature decreases, the resistance will also decrease. Okay, so if you try to reach this temperature of 27 minus 273, before that only the resistance also will become the superconductor.
Okay.
Okay, so it's something which cannot be reached. Even where there is no sunlight reaching over there also, you will not be able to find the temperature of minus 273.15.
Sir,
Okay,
what about Neptune and Uranus?
anywhere, if there is a
Okay.
molecule and that molecule is moving, so there is
Okay,
some
it's
amount
more
of
than
energy.
minus 273.15.
Yeah, it's more than minus 273.1.
Okay,
If the
sir.
molecule has stopped completely, then only it's 0 Kelvin.
Yes,
Okay.
sir.
So that's why it's not possible that you have anywhere a temperature of less than 0 Kelvin. So that's why your Kelvin temperature will always be positive. It will never go negative. So here in the kinetic theory of gases, we will study these things. We will study the variation of pressure, volume, and temperature. These are the three variables that we study: pressure, volume, and temperature. We also call them as gas laws. Gas laws. These gas laws, they are namely called as Gay-Lussac's laws, Charles law, and Boyle's law. So it's
Gay-Lussac
Gay-Luss,
has given the gaseous theory of.
yeah. So Gay-Lussac, if Gay-Lussac's law, then you have Charles law, and you have Boyle's law. So, as we know that there are three thermodynamic variables which have to be studied. The variables are pressure, volume, and temperature. So, in the Boyle's law, Boyle studied this with the help of keeping the temperature as constant. He kept temperature as constant and he studied the variation of pressure with volume. So, at constant temperature, At constant temperature, the pressure of the gas is directly proportional to volume. So we have also pressure of a gas is inversely proportional to volume. Okay. So let's see how he finds out that pressure is inversely proportional to volume. So first of all, the temperature of the system is to be maintained constant. Such such temperature, if you have any working substance, suppose here we take a gas. Okay. So this is a container in which we have put your gas, and so let's say these are the molecules of the gas. Now the upper part, this one is the piston. So piston is the part which can be moved up and down. This is similar to the part in your syringe. If you observe a syringe, so a syringe has a part that can be moved up and down. Okay, syringe looks something like this. So in that you have a body of the syringe, you have the body of the syringe, and inside the body of the syringe you have something here which can be moved up and down. Okay, so the
Okay.
body of the syringe is called as the cylinder, and this one we call as the piston, which can be moved up and down. So here we have the piston. So what will happen if the pressure of the gas increases? So if we try to increase the pressure of the gas, what will happen? The
It'll get
volume of the gas
compressed.
will decrease.
Okay. Yes.
It will go down. This piston will move down. If I increase the pressure, if I suppose add some masses on this, so the pressure will increase, and hence if the pressure increases, the volume of the gas will decrease. If you push from the top, if you are pushing from the top, so what will happen? The volume of the gas will decrease.
How does the volume decrease in this?
Okay, if you are pushing it from the top, so what will happen?
Molecules will get closer.
Molecules will get closer. That means this piston will come down.
Ah.
Okay. So if the piston comes down, isn't the volume decreased?
Yes.
Hasn't the volume decreased now? So now the volume has decreased. So
Okay.
this is the variation of pressure and volume with keeping the temperature constant.
Yes.
Okay. So if temperature is constant, we observe that pressure is inversely proportional to volume. Then other way also you can apply. If you increase the volume, if volume increases, so pressure must decrease. Or if you decrease the pressure, the volume will increase. For example, suppose if you have earlier put some weight over here, so that this piston is not allowed to move upward. If you decrease the pressure, the volume will increase.
Yes.
Okay. So here we say that pressure is inversely proportional to volume of a gas, and this was studied by the Boyles. The law was called as Boyle's law. So we can state that according to the Boyle's law, pressure is inversely proportional to volume
At constant temperature.
at constant temperature. Okay. So then we can see the other two laws also in the similar way, the Charles law and the Gay-Lussac's law. In the Charles law, it is the variation of volume with temperature, keeping pressure as constant.
Yes.
Okay. So in the Charles law, we observe here that volume is directly proportional to temperature. So if the pressure is constant, we are not going to increase or decrease the weight. And suppose if you start heating it, if you increase the temperature. So if you increase the temperature, the volume of the gas will also increase.
Yes.
Okay. So the stage we call as the Charles law. We just studied before, we plotted the graph between volume and temperature. So this is because of the Charles law. Then the Gay-Lussac's law. So we'll do according to the Gay-Lussac's law, we will have the variation of pressure and temperature. We observe that pressure is also directly proportional to temperature if volume is constant.
Okay.
Okay. So if you suppose if the volume has to remain constant, and if you increase the pressure, so if you increase the pressure, the temperature of the gas will increase. Okay.
I
Or
didn't get it.
if you supply some amount of heat to the gas, so the temperature of the gas will increase, and as a result, the pressure will also increase. So pressure is directly proportional to temperature. This is the Gay-Lewis axiom. Okay. So we'll discuss the gas laws in our next class also.
Okay, sir.
Okay, Shreyasi? So by Shreyasi, we'll start with this kinetic theory again in the next class.
Yes.
Okay.
Thank you, sir. Bye.
Goodbye. Bye, Dhananjay.